Welcome to this podcast where we're going to look at using unit rate to solve problems. In the last video, we looked at how to set up the answers to some problems, but we didn't have to find that many answers. This one, we're actually going to have to figure out the answers. So, for starters, let's turn to page 45 in your packet. And we'll look at question number 1 for starters. The good news is we get to use our favorite math tool to solve a bunch of these, proportions. So let's look at number 1. If a dozen donuts cost $2.50, how much would you pay for 1.5 dozen? Okay, let's set up a proportion. Think about what we're comparing here. We're comparing dozens of donuts to their cost, or to how much money. Okay, so now that we've got it, kind of the frame set up, let's fill it in. What do we know? A relationship between how many dozens and cost. We know that a dozen, or 1 dozen, costs $2.50. So we could fill that in as 1 dozen is 2.5, and you could write it as 2.50 if you wanted. That's all right. And then what else do we know? How much would you pay for 1.5 dozen? Well, y'all probably like decimals better than fractions, so 1.5 dozen would really be 1.5 dozen. Where would that go in our proportion? Well, that's dozens of donuts, so that would go up top. And now we're trying to find how much would you pay. So the dollars will be X. All right, let's go ahead and work that out. We know we're going to multiply these two and then divide our answer by that last thing. So let's go ahead and do that. I'm going to move over to my scratch paper, and I'm going to multiply 2.5 by 1.5. You can go ahead and do the same. Okay, so I get an answer of X equals 3.75. And so we check, and sure enough, there it is. Choice B, 3.75 for 1.5 dozen. Excellent. Let's look at the next one. Number 2. At a construction site, 12 workers can unload 10 crates of supplies in 4 hours. How many workers would be needed to unload 40 crates in the same amount of time? Okay, be careful here because look, there's like 3 things going on. Workers, crates, and hours, but we need to see what we really need in our proportion. So let's check that last sentence again. How many workers, so we're definitely going to need workers in there because that's what we're looking for, would be needed to unload 40 crates, so we're going to have to compare workers and crates. The 4 hours, they said the same amount of time, so that doesn't change, and it actually doesn't have to do with this problem. They're just throwing in another number to try to trick us. Okay, let's fill in what we do know about workers and crates. 12 workers can unload 10 crates. Okay, what else? How many workers would be needed to unload 40 crates? Well, where does the 40 go? That's got to go down here with crates, and so the number of workers will be X, what we're trying to find. Okay, go ahead and work that one out. I get an answer of X equals 48, but do work it out and check it. Pause the video if you have to. And so that would match up with answer B if my math is correct. Let's try number 3. Dylan wants to drain a water tank on his property. If the water drains at a rate of 1.8 gallons per minute, how many gallons will drain from the tank in 1 hour? Okay, we need to set this one up very carefully. We know we're going to be doing a proportion, and we'll compare gallons to something. Would it be better to compare gallons to minutes or gallons to hours? And really, for our sake, for the numbers, let's do gallons to minutes, and you'll see why here in just a second. We know that 1.8 gallons drains per minute. What does per minute mean? How many minutes is that? 1 minute. And so that's why it makes more sense to do 1.8 gallons per minute rather than to have the bottom be hours. Okay, let's see if we can set up this other side. How many gallons, so that's going to be X, we don't know what that is, will drain in 1 hour. Okay, we need to be careful. We can't just put a 1 down here. Because we're talking about 1 hour. How many minutes are in 1 hour? 60. So there's where they're trying to trick us. We have to be really careful there. Okay, got the tough part done, proportion set up. Go ahead and work that one out. 60 times 1.8. I don't know about y'all, but I end up with an answer of x equals 108. But do check my math in case I made a mistake. All right, let's see if our answer's there. Not 54, not 70. Our answer is not here. Okay, and sometimes that happens. We'll just double check our math. 1.8 times 60, 48, 10. Nope, that looks good. Looks like we didn't make a mistake there. So sure enough, our answer is 108, and it's just not here. Okay, let's do number 4. The water level in an aquifer rises 2.5 feet for every 2 inches of rain that falls over the aquifer's recharge zone. How much would the water level in the aquifer rise if 10 inches of rain fell over the recharge zone? Okay, let's look at what we're comparing here. We're comparing the feet that it rises over the inches of rain. So let's set up a proportion. We know that it rises 2.5 feet every 2 inches of rain. So that's a pair. What else do we know? How much would it rise if 10 inches of rain, so 10 inches of rain goes on the bottom, and x is how much would it rise? Okay, we've got our proportion set up. Let's go ahead and work that one out. Okay, I worked that one out and got 12.5, but do check and make sure that's correct. So 12.5, which of these answer choices matches up with that? Well, it's definitely not 11. 12.25, is that 12.5? Nope. That would be 12.25. 12.5 is 12.5? Sure enough. So our best choice is answer C. Okay. So hopefully this has helped you remember how to set up proportions and how to solve problems involving unit rate. I want you to complete questions 5 and 6 on this page, page 45, as well as I need you to then flip over and complete the 6 problems on page 46. Great work.